Sunflowers follow the sun throughout the day, absorbing additional solar energy and using it for photosynthesis. By that logic, solar panels should be able to follow the sun to absorb more energy as well. How much more energy would they absorb this way? Is it worth the cost of equipment and the energy it takes to power it? Using 3D printed parts, gears, motors, light-dependent resistors, and an Arduino microcontroller, I was able to build a device that angles a solar panel towards a light source, just as sunflowers do. Depending on how much light is detected by each photoresistor, the Arduino will send signals to each motor, angling the panel towards a light source. The way I am able to track the light source is to measure the voltages between constant resistors and those that vary with light. I built and mounted this circuit with the help of Dr. Wilson's expertise and his soldering iron. I will be able to monitor the power over time with the Arduino by loading the solar panel with a 50 ohm resistor and measuring the voltage. At first, the motors would tick very slowly and not respond to signals from the Arduino. This happened when I was powering the circuit through the USB connector. This problem was fixed by powering it through a 9-volt battery, providing enough energy to power the motor. Originally, when the structure found a stationary light source, it jiggled in place. To fix this, I changed the code to rotate the motors at a decreasing increment as it got closer to pointing at the light source. Changing the code to alter the rotational speed of the motors as they pivot toward the light source will not only allow it to move faster when it has a longer distance to go, but also prevents a jiggling effect as shown before. It stays stable. Now that the sun tracking device is built and working, we can collect data to determine how much more efficient a panel can be when it tracks the sun as compared to a fixed panel. I can also alter the code to deal with issues when putting the panel in the sun, such as what to do when it becomes cloudy. I look forward to updating this video with the results.